different types of neural networks have been built to excel at different types of problems. For example, convolutional neural networks are designed to mimic the way the human brain processes vision, and so these models excel at vision classification tasks. Neural networks seem to do pretty well at analyzing images, but often still struggle to analyze language. Before transformers, the best thing we had for language was recurrent neural networks. Let's say we want to translate a sentence from English to French. A recurrent neural network would take one word of the input sequence at a time, process it, and then sequentially give the translated output one word at a time. The sequential aspect of this process is important. If you shuffle words around in a sentence, you can often change the meaning of the sentence or remove any meaning from it whatsoever. So being able to preserve the word order by dealing with words sequentially is important. But recurrent neural networks really struggled when the input text was long, such as an entire essay. Once they get towards the end of the piece of text, they'd forgotten what had been said at the beginning. This is a real problem, as it will miss important context from earlier in the text that may be important throughout the whole input. For our language models to work effectively, they need to have some sort of memory of what was said earlier in the text. Take, for example, the following sentence. The New York Times is a daily newspaper. It was first issued in 1851. In the second sentence, it refers to the New York Times from the first sentence. But we would only know this if we were able to keep in memory what was mentioned in the first sentence. If we were only able to look at each token at a time, or tokens that are very close to each other, then we would not be able to truly understand the meaning of the second it, and thus the meaning of the whole text may be lost or misunderstood. By also processing words sequentially, it means that recurrent neural networks couldn't parallelize well. If we break up a piece of text to run in parallel, the recurrent neural network has no way of passing important contextual information within the text between itself. This means that training would often take a very long period of time, and it limited the size of the datasets that could be used for training. Recurrent neural networks would not be able to handle the size of the training data we see used for large language models today. It would just take too long. This is where transformers come in. Not only do transformers work in such a way that we can utilize parallelization, but they also have a novel way of being able to pay attention to the most important words in the text required for context. This means that transformer models can have a superior understanding of contextual information in the text. You might notice I said that transformer models are able to pay attention to the most important words in a piece of text. Attention is the name given to the technique that allows the transformer to pay attention to specific words. Let's now move on to our next lesson, where we cover attention in more detail and see how it's enabled the incredible language models we see today.